Azure Storage is a cloud storage solution provided by Microsoft Azure that offers highly available, secure, and scalable storage services. It supports various data types, including blobs, files, queues, and tables, making it versatile for different application needs. Azure Storage is designed to handle massive amounts of data, ensuring durability and redundancy through replication across multiple data centers. This introduction sets the stage for understanding how to implement storage policies and manage data lifecycles effectively within the Azure ecosystem. Storage policies in Azure are crucial for managing data efficiently and cost-effectively. They define how data is stored, accessed, and retained, ensuring compliance with organizational and regulatory requirements. Proper storage policies help optimize performance, reduce costs, and enhance security. By setting clear guidelines on data classification, access controls, and retention periods, organizations can ensure that their data is managed in a way that aligns with their business objectives and legal obligations. Data Lifecycle Management, DLM, involves managing data from its creation to its eventual deletion. In Azure, DLM helps organizations automate the process of moving data through different storage tiers based on its usage and importance. This ensures that data is stored cost-effectively while remaining accessible when needed. DLM policies can include rules for data retention, archiving, and deletion, helping organizations maintain control over their data and comply with data governance policies. Azure Blob Storage offers different tiers to optimize cost and performance based on data access patterns. The hot tier is for frequently accessed data, providing low latency access at a higher cost. The cool tier is for infrequently accessed data, offering lower storage costs with slightly higher access latency. The archive tier is for rarely accessed data, providing the lowest storage cost but with higher retrieval latency. Understanding these tiers is essential for implementing effective storage policies and data lifecycle management strategies. Implementing storage policies in Azure involves defining rules and guidelines for data storage, access, and retention. This includes setting up access controls to ensure that only authorized users can access sensitive data, defining data classification schemes to categorize data based on its sensitivity and importance, and establishing retention policies to determine how long data should be kept before being archived or deleted. These policies help organizations manage their data more effectively and ensure compliance with regulatory requirements. Azure provides tools and services to automate data lifecycle management, reducing the need for manual intervention. Azure Blob Storage lifecycle management policies allow organizations to define rules for moving data between different storage tiers based on its age or access patterns. For example, data can be automatically moved from the hot tier to the cool tier after a certain period of inactivity, and then to the archive tier if it remains inactive for a longer period. This automation helps optimize storage costs and ensures that data is managed efficiently throughout its lifecycle. Configuring lifecycle management policies in Azure involves creating rules that define how data should be moved between different storage tiers. These rules can be based on various criteria, such as the age of the data, its access patterns, or specific tags assigned to the data. Azure provides a user-friendly interface and APIs to create and manage these policies, making it easy for organizations to implement and maintain effective data lifecycle management strategies. Proper configuration ensures that data is stored cost-effectively and remains accessible when needed. Monitoring and auditing are essential components of effective storage policy management. Azure provides tools like Azure Monitor and Azure Storage Analytics to track the performance and usage of storage resources. These tools help organizations identify potential issues, optimize storage performance, and ensure compliance with storage policies. Regular audits can also help detect unauthorized access or policy violations, enabling organizations to take corrective actions and maintain the integrity and security of their data. Implementing best practices for storage policies can help organizations maximize the benefits of Azure Storage. These practices include regularly reviewing and updating storage policies to ensure they align with changing business needs and regulatory requirements, using encryption to protect sensitive data, implementing access controls to restrict data access to authorized users, and leveraging automation to streamline data lifecycle management. By following these best practices, organizations can ensure that their data is managed efficiently, securely, and cost-effectively. A leading e-commerce company successfully implemented data lifecycle management in Azure to optimize their storage costs and improve data accessibility. By categorizing their data based on usage patterns and business importance, they created lifecycle management policies that automatically move data between different storage tiers. This automation reduced their storage costs by 30% and ensured that critical data remained accessible for business operations. The case study highlights the importance of understanding data usage patterns and leveraging Azure's tools to implement effective DLM strategies. Implementing storage policies and data lifecycle management in Azure can present challenges, such as managing large volumes of data, ensuring compliance with regulatory requirements, and maintaining data security. Solutions to these challenges include using Azure's built-in tools for automation and monitoring, regularly reviewing and updating storage policies, and implementing robust access controls and encryption. By addressing these challenges proactively, organizations can ensure that their data is managed effectively and securely in the Azure environment. The future of data management in Azure is likely to be shaped by advancements in artificial intelligence and machine learning. These technologies can help organizations analyze data usage patterns more accurately and predict future storage needs, enabling more effective storage policies and data lifecycle management. Additionally, the increasing focus on data privacy and security will drive the development of more robust compliance and encryption features. Staying informed about these trends can help organizations prepare for the future and continue to manage their data effectively in the evolving Azure landscape. Implementing storage policies and data lifecycle management in Azure is essential for managing data efficiently, reducing costs, and ensuring compliance with regulatory requirements. By understanding the different storage tiers, automating data lifecycle management, and following best practices, organizations can optimize their storage strategies and maintain control over their data. Regular monitoring and auditing, along with staying informed about future trends, will help organizations continue to manage their data effectively in the Azure environment. The key takeaways include the importance of automation, the need for robust access controls, and the benefits of regularly reviewing and updating storage policies.